Okay, children. So, gravitation lesson we will discuss today, children. Gravitation. Okay, children. In gravitation lesson, children already have told you so many times, but small summary I will give children. So, imagine two planets are separated by distance r. Imagine two planets are separated by distance r. Okay, or else what I will do, children, today I will discuss only universal law of gravitation and some numericals on universal law of gravitation so that you will get full clarity, children. Okay, so children, two planets are heavenly bodies are there whose masses are m1 and m2 separated by distance r. They may attract or they may repel with a force which is directly proportional to product of their masses. They may attract or they may repel with some force. That force is directly proportional to product of their masses. Means what? More is the mass, more is the force. Less is the mass, less is the force. More is the mass, more will be the force of attraction or repulsion. We don't know. And this force is inversely proportional to square of the distance between them. This force, children, is inversely proportional to square of the distance between them. Okay, children. Normally, what we will do, children, we will remove the proportionality constant. When you remove the proportionality constant, what happens, children? When you remove the proportionality constant, tell me what happens. Anyone? When you remove the proportionality constant, what happens, children? We have to keep some f is directly proportional to m1 m2 by r square. So if you remove proportionality, we have to keep a constant g m1 m2 by r square. Okay, children, g m1 m2 by r square. Okay, children. So normally what happens means this this g is called as what? What is this g called as? G is called as universal gravitational constant. Universal gravitational constant. Universal gravitational constant, children. This g is called as universal gravitational constant. Okay, children. So now what happens means this is the formula for force of attraction or repulsion. Bring this r square here. Fr square is equal to g m1 m2. Bring m1 and m2 down, children. G is equal to fr square by m1 and m2. Okay, children, fr square by m1 and m2. Now what happens means, children, see here. So G is equal to F means we know units newtons, R square means meter square, kg into kg is kg square. What is the unit of G, children? G units are Newton meter square per kg square, and the value universal gravitational constant will not change from place to place. All over the universe it is same, and its value is 6.67 into 10 to the power of minus 11 Newton meter square per kg square. You should remember this value. What is the value of G? 6.67 into 10 to the power of minus 11 Newton meter square per kg square. 6.67 into 10 to the power of minus 11 Newton meter square per kg square. This is F, children. Okay. This is how. And suppose, children, we know F is equal to G m1 m2 by r square. From Newton's second law, what is F, children? Anyone? From Newton's second law, what is F?
MA.
MA. G m1 m2 by r square. If you write this MA as mg, m1 m and 1 m cancel. So if you write acceleration as acceleration due to gravity, gm by r square. Like this also you can write, children. So this is universal law of gravitational constant. Okay, children. Based on this, we'll do some small numericals. Then you'll understand how to do the sums. First question, children. First question. If you know, you can tell me the answer, children. Find the force of gravitation between two bodies of mass. One mass is 70 kg. Another mass is each of 70 kg. Both are 70 kg. Separated by a distance of 14 centimeters. Who will tell this sum? How to find the force between them? Who will tell? Who will tell this sum? Anyone in the class? You have to substitute in this formula, that's all. This
Sir,
formula.
can I
Tell now. Very good. F is equal to
F equals to Gm by G by R square.
okay. Keep saying.
F equals to 6.67 into 10 to the power of minus 11
Okay, very good.
into 70 into 70
By
by
14 centimeters. They are separated by 14 centimeters.
14
Okay,
square.
14,
14 into
14.
14.
Yeah, 14 into 14 correct only, Nana. But this is in centimeters. How to convert into meters?
By 100.
By 100. Okay, na? This two zeros will go up. So what you get, Nana? 6.67 into
6.67 into 10 to the power of minus 11 into
7 into
70.
7 into 1, 2, 3, 4, 5, 6. I will write as
10
10
to
to the
the
power
power of
6.
6
By,
by 14 into 14.
yeah, 7 2s are 14. 7 2s
7 to
are
0
14. So 6.67 into 10 to
to
the
10 to
power
the
of
power of
minus
10.
5 by 4. So how much it will become? How much it will become? 1.6675. 1.6675 into 10 to
Into
the
10
power
to the
of
power of
5
minus 5 Newton.
Newton. Like this, you should do, children. Very good, Dharmi. Very good. Okay, children, direct substitution. This is a formula. Any two bodies on the earth, any two bodies in the universe, they may attract or they may repel with a force directly proportional product of their masses, inversely proportional to square of distance between them, coming both m1 m2 by r square, even proportional to keep a constant g, where g is called as universal gravitational constant, and if f is equal to m in mgg, the relation between small g and big G is gm by r square. You have to learn this definition. In the Sunday exam, if I ask derive universal law of gravitation, still here you have to derive. And basing on this, one numerical also I will give. Those who understand this, good. Those who didn't understand, one more question I will just say. Let's see here. One more question. Second question. Calculate the force of attraction between 80 kg man and the earth. Okay, there is one man who is 80 kg and between earth weight is 6 into 10 to the power of 24 kg, and the radius of the earth is given, we know radius of the earth is 6.4 into 10 to the power of 3 kilometers. Yes, anyone wants to say this? Same, children, we have to find the force. Same, anyone? Who will tell?
Sir, can I say?
Yeah, tell me.
F is equal to G m1 m2 by r
F is equal to g m1 m2 by r square. Keep saying, very good.
6.67 into 10 to the power minus 11
Okay,
into
into
6 into
80 into 6 into
10 to the power 24.
by
6.4 into 10 to the power 3
kilometers to meters, kilometers to meters into
into
into thousand, into thousand, into thousand means 10 to the power of 3 whole square now. Yeah, tell me.
6.67 into 10 to the power minus 11 into 480 into 10 to the power 23 by 10 24 by
10 to
6.4
10
into
power of 3, 10 power of 3 is 10 power of 6. 10 power of 6 into 2,
10 to the power 12.
12. Okay, children. So, uh,
Sir,
this if I remove, here it will become 5. 6.4 into 6.4 because 6.4 whole square. So children, if you simplify this we have to simplify, children. 6.67 into 48 into 6.4 into 6.4 into 10 to the power of 25 minus 11, 40. 14 minus 12, 2. Okay, children. So how much it is coming means approximately it will come, children. 8 into 10 to the power of 2 Newton. This whole thing will come as 8, children. 8 into 10 to the power of 2, that is 800 Newton is the force of attraction between this man and the earth. The man 80 kg and this earth, the fellow is 800 Newton. Okay, children. You all know that also. How W is equal to mg, we also know that. W is mass of the man is 80 kg. G on the earth approximately 10, 800 Newton. That's all, no, children. Same unit. Same unit. I told you, no? Same unit. Those who didn't understand, one more question, children. Those who didn't understand, one more question. Okay. What is the force of attraction between two objects of mass 1 kg? Both are 1 kg unit, children, and separated by a distance of 1 meter. Who will do this? Who will do
So can
this?
I say?
Yeah, yes, yes.
So F is equals to G m1 m2 by r square.
Super.
F is equals to 6.67 10 to the power of minus 11 into 1 into 1 by 1 into 1.
So answer?
F is equals to 6.67 into 10 to the power of minus 11 newtons.
Newton is the force between these two bodies. Very good. Those who didn't understand, one more question for you. A sphere of mass 20 kg, one is 20 kg, another is 10 kg, are separated by 20 centimeters. Okay, and the force of attraction between them, if force of attraction between them is 3.3 into 10 to the power of minus 7 Newton, find G. G is constant, but for variety they gave children. Yes, who will learn this one?
Sir, can I say?
Yes, Nandita.
F is equal to G m1 m2 by r square.
Okay.
3.3 into 10 power minus 7 is equal to
Okay.
G into 20 into 10 into 20 into 10 by 20 by 100 whole square.
Okay.
20 by 100 into 20 by 100.
This 20, this is 2 Nana. This 100, this 100 I will send up. So how much it will become?
3.3 into 10 power minus 7 into 4 into 10 power minus 4.
G into 100 into 100
10
by 2.
by 2.
This
So
2 goes up.
6.6 into 10 power minus 7 is equal to 4 into 10 power 4. 6.6 G is equal to 6.8. 6.6 into 10 power minus 7 by 10 power 4. Sir, then 4.
Bring it up.
Okay. 6.6 into 10 power minus 7 minus 4. G is equal to 6.6 into 10 power minus 11.
Newton meter square per kg square. Unit, very good. Value of G is Newton meter square per kg square. Units of G is Newton meter square per kg square. Value of G is Newton meter square per kg square. Okay. Those who need to understand, one more sum for you children. How many sums you do, that much strong you will become in physics children. Always. Okay. Next question. Compare the gravitational force by the sun and the moon on the earth, children. Mass of earth is 6 into 10 to the power 24. Mass of sun is 2 into 10 to the power of 30 kg, and distance between moon and sun, distance between earth and sun is 1.5 into 10 to the power of 11 meter. Can anyone tell how to do this? Who will tell? Who will tell? Yes.
Shall I?
Yeah, who is that?
Aisha, sir.
Tell now. Very good. Very good.
F is equals to G m1 m into m2 by r square.
Okay.
6.67 into 10 to the power minus 11 into 6 into 10 to the power 24 into 2 into 10 to the power 30 by 1.5 into 10 to the power 11 square.
Okay.
So 6.67 into 12 into
24 plus 30.
54.
Okay. 1.5 into 1.5.
3 1 2
11
2.5
twos are
11 22.
Okay, so 6.67 mute your audio. So 54 minus 11 is 43 children. 54 minus 11 is 43. 43 minus 22. 43 minus 22 is 21 children. So 10 to the power of 21. So Saisha, approximately this one you will get, I will say, no problem. I will say, this children, can anyone help me out children? How much it will come? 6.67 into 12 by 2.25, anyone?
35.57.
35.57 into 10 to the power of 21 Newton is the force of attraction between Earth and the Sun, children. Earth and the Sun, children. Okay, so like this. Next, fifth sum, children. This is next. One more question, children. Sixth question. A sphere of mass 40 kg and other one is 60 kg. One sphere is 40 kg, another one is 60 kg. Are separated by attracted with the force of are attracted with the force of, see here children, attracted with the force of 4 into 10 to the power of minus 5 Newton. G is take 6 into 10 to the power of minus 11. Find distance between these two bodies. Distance between these two bodies we have to find. Snigdha, can you tell how to do this one?
Yes, sir.
Yeah, please tell me. F is equal to?
For F is equals to G M1 M2 by R square
Okay.
is equals to for it's 4 in 6 in 0 7 40 into
60
60
by R square.
divided by
Actually, 6.627 only, correctly, but they told here to take 6 into 10 power minus 7.
okay,
Okay.
sir.
Bring this up, take this down.
R square is equals to 6 into 10 to the power of minus 11 into 40 into 2400 into 10 into 4 into 10 to the power of minus 5.
4 6 are 24, okay?
Yes, sir.
6 6 are?
36.
Okay, 6 square we will put, okay. Then
100.
minus 5, if it comes up, plus 5.
Yes, sir.
6 7. Okay? Minus 11 plus 7 is how much? Minus 4.
Minus.
Minus 4. So what we can write? What we can write? R square is equal to 6 square into 10 to the power of minus 2
Minus 2
whole
to the
square.
power of 2.
Square 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 cancel. So R is equal to 6 into
6
10 to
into
the power of minus 2.
minus 2.
6 by
100.
100. 0.06 meters. That is 60 centimeters. 60 centimeters. Okay, children? Like this you have to do, children. Next question. Boys are not at all telling. All girls will only say. No boys, huh? Vivek? The mass of the planet Jupiter is
Yes, sir.
1.9. Come on. Mass of planet Jupiter is 1.9 into 10 to the power of 27 kg. This is Jupiter mass. And that of the mass of the Earth is mass of the Sun. Mass of the Sun is 1.99 into 10 to the power of 20 kg. And the distance between Jupiter and Sun is 7.8 into 10 to the power of 11. Find the force of attraction or repulsion between Jupiter and Sun.
Yes. Sir, force is equal to 6.67 into 10 to the power of minus 11 into 1.9 into 10 to the power of 7 into 1.99 into 10 to the power of 20, sir, by 7.8 into 10 to the power of 11 into whole square, sir.
So
F is equal to
6.67 into 1.9 into 1.99 by 7.8 into 7.8
7.8 into
27 plus 20, 47. 47 minus 11
47,
is 36.
36,
By 10 to the
36,
power of 22.
36 minus 22.
Can anyone help
That
me
is
solving this? Anyone? Dash into 10 to the power of 14 Newton. Can anyone help me solving this, children? 4 point. Okay. 22, no, this is 36, no. 47 minus 11 is 36 only, no. 36 minus 22 is 14 only, no. Did we do anywhere mistake, children? Any mistake we did? Why did they give like this? Okay, 27. 20 minus 2. Okay, they took wrong, children, no problem. They took wrong, that is their mistake. So this is 4.145 into 10 to the power of 14 Newton is the
And
force of
yes, sir.
attraction between Jupiter and Sun, children. This is
They asked if it's repulsion or attraction, right?
anything. It may be force of attraction or repulsion. It's none of our business. Okay, so like that they will attract or they will repel, children. One more question. Those who understood very well. One more question, children. I hope you are understanding now. Now small sum will give. Okay, so Srihita is there. Srihita. Srihita is not there.
Can I say?
Who will tell? Who will tell?
Sanchita.
Hansika, tell now. Yeah.
F is equals to G M1 M2 by R square, 6.67 into 10 to the power minus 11 into 2 into 3 by 1 into 1 square. F
Okay.
is equals to 6.67 into 10 to the power minus 11 into 6 by
How much?
4.02 into 10 to the power minus 11 Newton.
Very good. Next, one more question. Mass is, children, mass is m1, other mass is m2, distance is r1. Now what happened? First mass is doubled, second mass is tripled, radius is made 4 times. What will be the change in force? What will be the change in force? What will be the change in force? This is F1, this is F2. What is the formula for F1, children? G m1 m2 by r square. If mass is doubled, another mass is tripled, radius is made 4 times, what will be the change in force? Like this questions you will get, children. See here, F2 is equal to G m1 m2 by r square. F2 is equal to G will not change. What is m1? M1 became how many times, children? 2 times. M2 became how many times? 3 times. Distance became how many times? 4 times, but r square. Okay, children, so F2 is equal to G into M1 into M2 into 2 3s are 6 by R1 square into 16. But G M1 M2 by R square is how much, children? F1, that is F1. So F2 is equal to F1 into 2 3s are 2 8s are. So it is becoming 3 by 8 times the original. It is becoming 3 by 8 times the original. Force is becoming 3 by 8 times the original. Those who didn't understand, one more sum I will do like this only, children. Try to understand. So many questions I am saying, children. Try to understand. So many questions I am saying. Okay. I'll see, children. Mass is m1, other mass is m2, our distance is r. Okay. Force is f1. F1 is equal to g m1 m2 by r square. Okay. Now mass is made half of original. Okay, directly will not go. 5 times. Another mass is made 6 times. Radius is made 2 times. What will be the new force? What will be the new force? What will be the new force? F2 is equal to G m1 m2 by r square. F2 is equal to G is G only. M1 is 5 m1. M2 is 6 m2 and R is 2 r1 whole square. Please try to understand. F2 is equal to G m1 m2 5 6 30 by r1 square into 4. This is what, children? F1. So F2 is equal to F1 into 15 by 2 times the original. Force is becoming 15 by 2 times the original. Force is becoming 15 by 2 times the original. Are you people able to understand, children, like these questions? Children, are you understanding, children? One more question I will give. If anyone are interested, you can tell, children. Original mass is m1, m2, r1 and formula is g m1, m2 by r square, you know. Now mass is, other mass is made half of the original. Okay, other is made 1/3 of the original. Radius is made 1/4 of the original. What will be the new force? Who will tell? G m1 m2 by r square. G is G only. What is M1, children? Half of M1. What is M2, children? 1/3 of M2. What is radius, children? 1/4 of original. Please, children, you have to concentrate on mark. So F2 is equal to G M1 M2 by 2 3s are 6 into R square 4 4s are 16 by 16. No, children, the 16 will go up. So children, what is this, children? This is F1. So F2 is equal to F1 into 2 3s are 2 8s are 8 4s are 32 by 3 times the original. Final force is becoming 32 by 3 times the original. Next force is becoming 32 by 3 times the original. Last sum, children. Anyone wants, you can try, children. I will give last sum. Okay, just for your practice and doing so many sums, children, so that you should never feel like uncomfortable when this question is coming in exam, children. Mass is becoming 3 by 4 times. Second mass is becoming 2 by 3 times. Radius is becoming 3 by 5 times. Find the second force. Who will tell?
Sir, can I try?
Yeah, no, please.
Sir, F2 is equals to
Okay. G.
G M1
M1 is
M 3 by 4 M1
M2
into 2 by 3 M2
by
by 3 by 5 R into R square
whole square. Okay,
into R
ma'am.
whole square.
Okay.
Yes, sir.
So F2 is equal to,
F2 is equals to
okay, G M1 M2 by
M2
R square. This is 3 by 4
into 3 by 4
into this is 2 by 3.
2 by 3
This is
into 3
9
by
by
5
9 by
9
25.
by 25.
9 will come here, 25 will go up.
25 will go up.
So this is F1. Yes, Nana, tell.
F1 into 3 cancel. 2 2s are 25 by 18
Times the original.
times the original force.
Yeah, F2 is becoming 25 by 18 times the original. Second force is becoming 25 by 18 times the original. Sometimes children they will ask how much is the percentage change? How much is the percentage change? Children 25 by 18. 18 is becoming 25. Is it increasing or decreasing? Anyone? Children, is it increasing or decreasing? Anyone at least tell this, sir. Why are you sitting like that? Children, 18 is becoming 25. Is it increasing or decreasing?
Increasing, sir.
Increasing.
Increasing. Percentage increase formula, what did I say, children?
Change by original into
Change is how much, children? Change 7. Original is 18 into 100. Can anyone help me? 700 by 18 is how much? 700 by 18 is how much? 350 by 9. 9 2s are 9 3 is 27. Yeah, 700 by 18 is how much? 350 by 9. 9 3s are 27.
38.8.
8.88.
38.88 or 89, we can say percentage increase in the force. Okay, F2, this F1 I got. So 18 became 25 means increase. How much increase? 38.88% of the force has increased. Like this, questions will come, children, according to the situation we have to do. I will give some more for practice numericals in the notes and I will send to you, children. Please try to practice them, children. This is about entirely about the force. This is universal law of gravitation. Tomorrow I will discuss next topic in this gravitation lesson. Children, hope you all understood. Thank you so much. If you have any doubts, you can ask me.